Hello बच्चों, let's read this question. So the question says, the French physicist Louis de Broglie in 1924 postulated the matter like radiation should exhibit a dual behavior. He proposed the following relationship between the wavelength lambda of a material particle, its linear momentum p, and Planck constant h, that is lambda equals h by p, that is h by mv. The de Broglie relation implies that the wavelength of a particle should decrease as its velocity increases. It also implies that for a given velocity, heavier particles should have shorter wavelength than lighter particles. The waves associated with particles in motion are called matter waves or de Broglie waves. These waves differ from the electromagnetic waves as they have lower velocities, they have no electrical and magnetic fields, and they are not emitted by the particle under consideration. The experimental confirmation of de Broglie relation was obtained when Davisson and Germer in 1927 observed that a beam of electrons is diffracted by a nickel crystal. As diffraction is characteristic property of waves, hence the beam of electrons behaves as a wave as proposed by de Broglie. Werner Heisenberg considered the limits of how precisely we can measure properties of an electron or other microscopic particle like electron. He determined that there is a fundamental limit of how closely we can measure both position and momentum. So, the more accurately we measure the momentum of a particle, the less accurately we can determine its position. The converse is also true. This is summed up in what we now call the Heisenberg uncertainty principle. That is, it is impossible to determine simultaneously and precisely both the momentum and position of a particle. The product of uncertainty in position delta x and the uncertainty in momentum delta mv must be greater than or equal to h by 4 pi. That is, delta x delta mv should be greater than or equal to h by 4 pi. So, if the uncertainty in velocity and position is same, so the uncertainty in velocity and position is same, then the uncertainty in momentum will be, and we have four options. So, here the key concept is Heisenberg's uncertainty principle. Uncertainty principle. All right. So यहाँ पर Heisenberg's uncertainty principle के बारे में given है that delta x multiplied by delta p or delta mv, or we can write delta mv should be greater than equal to h divided by 4 pi. And यहाँ पर given है if the uncertainty in velocity and position are same. Uncertainty in velocity is delta v and uncertainty in position is delta x. So delta v is basically equal to delta x. Delta v is equal to delta x. So यहाँ पर हमें determine करना है uncertainty in momentum, that is delta mv. Delta mv की वैल्यू क्या होगी? So यहाँ पर हम let us say this is equation 1. Equation 1 में हम put करेंगे delta x is equal to delta v. So delta v multiplied by delta mv is equal to h divided by 4 pi, and we can also write delta m multiplied by delta v square is equal to h divided by 4 pi. All right, h divided by 4 pi, क्योंकि यहाँ पर डेल्टा एम वी को हम एक्सप्रेस कर सकते हैं डेल्टा एम मल्टीप्लाइड बाय डेल्टा वी में. सो डेल्टा वी का स्क्वायर हो जाएगा इधर, एंड वी विल गेट डेल्टा वी इज इक्वल टू h divided by 4 pi. Now we know that mass of substance constant रहता है, so we can write it as h by 4 pi m delta v whole square. And in the next step we can write डेल्टा V इज इक्वल टू h by 4 pi m का square root. So delta V is equal to square root of h divided by 4 pi m. Now we have to determine the uncertainty in momentum, delta mv, which is equal to m multiplied by delta V, which is equal to m multiplied by delta V, that is h by 4 pi m का square root, h by 4 pi m square root. So यहाँ पर m और m cancel हो जाएगा and m यहाँ पर ऊपर आ जाएगा. So we have delta P is equal to mh divided by 4 pi and इसका square root. So ये जो है ये correctly given है option A में. So our correct answer is option number A. This is the required solution and I hope you understood the concept well. Best of luck.